Hello, everyone.
Hello, everyone.
Very pleased to be here at the Tech Forum today. So let's start our presentation with Yassine. So we are historically two mobile developers, and the idea of the presentation is to open all our minds on this presentation.
And our hearts.
And our hearts, of course, because you will love Kotlin, and because it's not only for mobile developers. Let's start. So I'm Ibrahim, part of the Tech Squad core team of Worldline, and this is Yassine.
I'm there. I'm not this one. Oh.
So let's raise our hand. What can we do with Kotlin today? Can we do backend development? Raise your hand if you think so. Can we do mobile development? Good. Desktop development? Web development? Okay, so
and much more.
This presentation is to show you that we can do that and much more. Yeah. So a bit of a story, because the Kotlin ecosystem has now 13 years. It's quite really young for a language, and we think that it have a promising future. So we divided in three major steps the language evolution. So the first one was the initial one, the language and the web and desktop support, which was initially at 2011 already available. So the major step there was the Kotlin itself. The availability of Kotlin as a language for Android, which push up the language itself thanks to Android. And also the project Kotlin multiplatform was released in beta 1 in 2017. Second step, Yassine.
Yes, as you can see, it's in this second step that Kotlin became more known as a mobile developer language, but it was released for initially for JVM and JS. But now in the second step, we see that Kotlin is renowned for Android development. And you see the first class on Android announcement from Google, many libraries, and so on. And we have the third step, where you see the Kotlin ecosystem going even more further than mobile, than just Android and iOS. It's multi-platform. So you see that we have Kotlin Compose, which allows to make, Ibrahim will talk about it later, which allows to make front-end across all platforms. And we have Kotlin 2, which was released recently. And you see this, we got it from Kotlin Conf, where the language was announced, the Kotlin 2. And so Kotlin is really going forward, expanding to many more platforms, and we can do everything with Kotlin.
Great momentum to start it. So let's go deeper on one part of the ecosystem, which is Kotlin multiplatform. So first question, how it works. Let's starting up. So you already know those platforms we mentioned previously. Now every platform has his own APIs that is natively available by the provider, by Google, by Apple, and by the other one. On the top of that, we have the project that we are just referring to, Kotlin multiplatform. The main purpose of this project is to provide a library with a common Kotlin shared code available to all the apps as a standard library, making it available. Everything is made thanks to Gradle build system, building everything to hide the complexity of making available the library on native language, on the native platforms. So this is the Kotlin multiplatform project. On the top of that, we have Compose multiplatform. Compose multiplatform is when we want to go further. It's okay on a standard clean architecture to have load data logic, network logic, business logic, and so on, multi-platform, but you want to make the common UI. And for that, it's a simple library that you're adding to your Kotlin multi-platform project. On this library, it's Compose multi-platform. It's declarative UI framework to be able to declare all your application, your views. And it's after that, with the mechanism that we will see, being able to provide the UI commonly with the same code on all the platforms.
So yeah, summary here. So you see that you can target many platforms in Kotlin. You can choose which platform to target, and even you can even go through do your UI with Kotlin.
Before going too deeper, let's go to the architecture. So let's see that as a standard clean architecture that you can have in common architecture code. You have the data and the core part, the business domain, the presentation, and the UI. So you can start a Kotlin project from nothing, meaning a Kotlin multi-platform. You have a new project, you're starting up with Art, the Kotlin multi-platform project, selecting your target. Or you can also starting up with an Android project and embedding it to a more multi-platform project and convert it as a multi-platform project, for example. Then you can start starting up common logic for some platforms, not the whole application necessarily. You can start with only, you have a merchant app, you have a catalog of products, you have the payment tunnel, you have the loyalty, and you can just decide to have a new feature and make it multi-platform and keeping the rest natively. So you can try it, in fact, even in production. Then you can say, okay, now it's really mature, it's okay, it's really fitting the needs, we just divided by 2 the costs for my platform. I can go deeper and I can just merge the whole data and business logic. We are still in Kotlin multi-platform project, KMP, okay? And the last part, this is what I'm referring, compose. Now I want to make some UI common. So even I can be flexible. I can say, okay, I want to add some views, multi-platform, for example, FAQ, any view that we want, and we can keep the complexity view, the complex view or the legacy views still on the native part of the application. So this is very powerful, and if you are not satisfied, you can revert quite easily. So this is the power of KMP. Let's go. Now we talk about native code, we talk about common code. How we can make sure that the contract between my native code and my common code is respected. It's really powerful and new in cross-platform development. We have a keyword dedicated on the language for that. On Kotlin, it's expect here and actual. So expect and actual is able to keep the contract. And for example, you have your common code that needs to get the platform build number or the platform, if it's iOS and the iOS number version, and the same for Android, and the same for the WebKit, and the same for the desktop. You can simply declare the function or the class that you want to be specifically made in native language. And then on the other part of your code, on the specific code, you can define actually the contract that you need by the keyword actual. What is good with Kotlin multi-platform is that if you are not making it on one platform that you support, the compile time at compile time, you will have complaint, and you will not be able to deploy because you didn't respect the contract. It could be for classes, it could be for functions, and much more.
And what you see here is really the original way of Kotlin for doing cross-platform, because here you see it's native iOS APIs. So Kotlin has more direct access to native platform APIs compared to other languages or other frameworks like React Native or Flutter, where it's not like direct access to the language APIs.
And you can see that, well, it's UIKit, it's Apple, it should be Swift, but it's not. Because Kotlin is encapsulate, and you are able to finally write and access to API directly in Kotlin. So you are not moving language even when you are doing native code. Let's continue. A bit of architecture, the state of the art today. It moves a lot since the last 6 months. Previously, there were lots of orange stuff here. Now, since the last Kotlin Conf, everything is stabilized. So this is the standard architecture of a Kotlin multi-platform project for the common code that you are dealing, how your architecture, clean architecture based. And it's really the copy-paste of the Android Jetpack Compose Android architecture pattern provided by Google for Android. So if you understand me, if you are starting up with an Android project, moving it to Kotlin multi-platform is theoretically at 0 cost. You're just moving it and making it available the other platforms. I I will not go into detail, but on the database side, you have some database library. The latest one from Google is Room Database that was now available since Kotlin Conf. You have also access to resource management. So kind of a challenge when you want to pick up images on all the platforms, the font and the strings. And you have access also to the navigation path, exactly like Android. There is also, for more advanced logic, for injection you have Coin, for asynchronous way of managing the database and the network, you have also the coroutines, Kotlin approach for asynchronous code. And also for business logic components such as Flutter, for who knows, you have also some library called Decompose that you will be able to do it. Okay. This is KMP. You see now the link with Compose. Let's go deeper on Compose. So Compose is a declarative UI style of making UIs initially with Google, with a Jetpack Compose library on Google, pushed by Google. And now they enable JetBrains enable Compose multiplatform, enabling Jetpack Compose as a multiplatform library. How you code it? So you have basically declaring like function style. You have your composable declaration. You have an annotation to precise that it's actually not a function, standard function, but it's a composable function where you will describe UI. And then you describe your UI as simple as that. You have some already available composables, and you can embed the other one inside as a child. And then you have here a card, here materialized. You can define some properties. You have columns. You can define a column. You can define some text, and you have a button here. So how the magic is making available, it's because behind that, it's not, there is a rendering library behind the Kotlin Compose library, which is called Skia. It's declined on every platforms and is able to render correctly with the same APIs but coded on the right native language. And it's kind of an alternative to OpenGL, more efficient for those kind of rendering.
So you have the choice when you do Kotlin multi-platform. You can use so Compose to have something similar to Flutter, to have a library render for you across all platforms. Or you can also choose to still use a SwiftUI or a Jetpack Compose for the native components. Maybe time for a demo?
This is the time for the demo. So the use case, really simple. You have a quiz app. You have a first screen with the welcome screen. You have the score screen at the end, and you have looping to the question on the question screen. Let's go to the demo.
Here, yeah.
So this is Android Studio. Welcome, Android Studio. So on Android Studio, I have already prepared multi-platform project. So let's start. So here I'm materializing the icon API because you can embed. It's not a Compose multi-platform. It's not multi-platform project, but you have a module. You have a module here, which is a server app, and you can embed as a monorepo your backend. Yassine will go deeper on the backend side, how to develop. Here you have all your target applications that will embed your library, your KMP library. Okay, you have desktop, you have GS, you have all the targets you are supporting, and the bridge is made for the UI here. You can see on all your folders, you will have a bridge to the main view that is actually on the common code. Okay, so this is how you boot up to the right composable views from the native apps. Okay, and because you have the package embedded on each part, you are able to start up your views. So now we are here on the common view, on the shared module. The shared module is where actually you are coding when you are doing multi-platform. And here I have the whole architecture. Remembering a bit, here you have data source repositories. Okay, data source repositories and the UI layer. So the UI layer is materialized by your screens. The navigation is permitting to describe the workflow between your screens. and you have the data source that you are needing. So data source are typically, you have some endpoints to call with a library, a third-party library to make requests to your endpoints. You have a data source. You have a database that you need to push up your here the list of questions. You are creating a data source, and I have also created a mock data source to be able to fake when I don't have any networks, to be able to retrieve a fake list, at least to have a question, even if I don't have any network. Okay, so the repository here, let me continue. The repository is created for making the orchestration of all the data source. I can create some rules. I need one to retrieve each 5 minutes if I already prepared my I create my rules for the network. Okay, if I didn't receive yet any request, let's request with the repository, the data source. Let's then use the database data source to be able to store the list of questions, etc. So now here, just a focus to the composable side. So as you can see, there is a plugin to be able to preview. So you are previewing only the desktop version for now. If you want to have the specific rendering, you need to go to the native apps to be able to see the previews. But here you can see the composables for all the screens. So again, and then you have the navigation host I mentioned to be able to say, okay, I have my initial route. I'm using it like URL. I'm creating my endpoints. So I have my welcome route, I have my quiz route, and I have the composable associated with it. And I define that initial route is the welcome screen to start up the composable. Okay, now we are in the repository. So you are instantiating all your data source. Here it's a bit ugly, clearly, because there is no injection. There is no, it's really simple, even not singleton pattern. Here I'm just instantiating like this, but at least you can see that all my data source is here, and I'm handling my data source. It's a bit below on the code, but it's really the heart of how I'm dealing with data sources. The repository is made for that. Okay. What's next? So here it's a data source. So the data source using the library Ktor. So Ktor is the client. It's a client-server library making available in Kotlin. So you have a server part for the backend part that Yassine will talk about, and the client part is here, and it's simply an HTTP client that you are declaring in the DSL style. And then you can call your endpoint asynchronously thanks to coroutines with the suspend keyword. Okay, now I think I need to speed up, Yassine, right?
Yeah.
No more pause. So the one last thing is regarding database generation. It's a simple SQ file. You have describing all your that table and all your function, and it's code generation, so it's generating all the code for the database for you, and then you can use it. And a bit tricky part here, sorry, is just that for the SQLite, you need to have a driver for each platforms. So this is where the expect actual keyword is needed, because I need to instantiate for all platforms the driver specifically. So how I can make it? So here I'm passing, it's a bit ugly again, no injection and so on the architecture, but here you have the SQL driver that you are passing to your views, and it needs to be here passed specifically for each platform. So here I declared a database driver factory. Let me check here, it will be open. So I have my SQL driver creator, and I declare it as expected, because on the command code I cannot instantiate a specific platform driver. So then I'm going to every specific code. So here I'm on the Android side, and I'm instantiating an SQL Android driver. And the same for all the other platforms. And this is how you can inject specific drivers and then use it in a command code.
It's pretty powerful.
web worker driver for the JS, and the same for iOS with the native SQL driver.
No more pause, huh?
Sorry, my bad.
No.
Just take the clicker. Okay, and here it's also the Gradle, the heart of the build system to make that happen. Here I'm declaring specifically for each platform the driver itself, the dependency of the driver on the Gradle file. Okay, so now time for the demo, a really short one. You can see that I'm starting the Android one, the desktop one, the iOS one.
Because why not?
Because why not? On the same base code. And the same for the web side. And I have also the backend inside. So I have a monorepo with every target available, even for the web.
Nice.
The job is done. Multi-platform. So let's go back to our presentation. We just see one side of the ecosystem. I let the floor to Yassine to show you some others.
Okay, thank you, Ibrahim. So let's talk. I hope your love of Kotlin increased a little bit. So let's increase it a little bit more, because in the front, so we'll go to the back end. So Kotlin has many, as you have seen, many facets. Thanks to that, you can do backend with Kotlin in many different ways. So if you are more of a JVM developer, or you really like the JVM frameworks, you can use all the JVM backend frameworks, and some of them have official support for Kotlin, like Quarkus and Spring Boot. They officially support Kotlin in their wizard, so you can go on with it from the get-go. You have pure Kotlin frameworks, which have the advantage of using all the features of Kotlin that are not available in Java, such as DSLs for writing declarative code. And you have also, if you want to do something more fun or exotic, you can write Node.js servers in Kotlin, because Kotlin supports transpiling to JavaScript.
Because why not?
Because why not? Of course. And I know some people that do it, so it works. And they have a demo also in the open source training that we provide. You can have a small project of Node.js in Kotlin. And there are many companies are using Kotlin on the server side. Here is an example here, and they are very satisfied. And the main advantages of using Kotlin is, of course, the features that you don't have in Java, like null safety, DSLs, the concise code, and so on. So you find this feedback across all the companies that use Kotlin on the server side. And there is a page with all the feedbacks. So please take a look if you want to have like a really true return of experience on using Kotlin for the backend. So let's take a quick look at how to make a Kotlin server with a Ktor server. So how it works is it's look like an Express if people here did some Node.js before, or some Express.js. So here it's more using a declarative style with DSLs, so the domain-specific language. So you define a route where you have a get to the root of your domain, and you have get to /fighters. And you define what the implementation of each route. So it's much more direct, no classes as you see here, only function code. And you get these two endpoints available when you run the server. So let's take a quick look at how it works. So is the video started? Right. So here you have the wizard. So similar to the wizard that you have on other backend frameworks, you create a new Kotlin, a new project on Ktor server. You choose the plugins, same way as you do when you create other on Spring, on Quarkus. You choose which technologies or which features you want to include in your server. And after that, you generate the project. So here we chose the basic stuff that we need to do a REST API, so JSON, a Swagger, it's the documentation that you have. And when you create the project, you have some documentation to get started. But let's go to the IDE, open the project, and run the server. So just with a Gradle task, Gradle wrapper run. So I use just small tip. Console plane allows to like show the input continuously. So it's a different input than the default input, which is more adapted for a server. So you have the Swagger, which is available. You can test it. So all of this is available for free when you create a project. So here you have the Swagger file, which documents your API. So here I added some list of fighters, and I'll add another endpoint.
I took Ryu, of course.
So as I'm a fan of Street Fighter, I have to work something like this. So let's start again the server. So there is a hot reload, but couldn't get it to work immediately. But hot reload is theoretically supported. So it's not it doesn't appear yet in the Swagger. You just need to add it by hand. Of course, there are ways to generate the Swagger file dynamically. You just need it's in the documentation. So here's just really quick introduction. I didn't go very deep into the automation, the automatic generation, but it should be available. And we run again after adding the Swagger file. So you run again the server, and you have the new documentation available with 2 endpoints. So you see how much easy to create is it to add endpoints, no classes, just add methods and define the behavior. Okay, so this is Kotlin for the backend. So our love has increased a little bit. So let's add the small final touch with Kotlin for data science, because data science is really getting more and more popular because we have a lot of tools, we have AI, we have a lot of data to work with. So we can do also data science with Kotlin. So what's the entry point, or what allows us to do this? One of the things that allows us to do this is the official support of Jupyter Notebooks. Do you know about Jupyter Notebooks? Do you know? Okay. So Jupyter Notebooks, thanks, at least one. So Jupyter Notebooks, they're used a lot by data scientists because it's a file which combines Markdown, so some rendering, some UI, with executable code. So in a single file, you have some code, some rendering, headers, text, paragraphs, italic, and you have code where you have a button, you click and you run it. So Python is the language that supports this file by default, but you can add what we call kernels, which allow to add more code to be executed by this file. And there is an official kernel for Kotlin. So here, let's take a look at a demo to see more. Okay, let's switch to the player. So here we have Markdown IP nib file. So it's a Python Jupyter Notebook file. You have some Markdown, and when you finish it, it's rendered immediately. After that, you can edit it on the fly. You have a preview. And here you have some Kotlin code. So yeah, it can be any language, but you can select to be run as a Kotlin code. And you have the result below. So here is Kotlin code. You have val, so it's constant. You can print, you can call, or you can print the result, and you have the result below. And you can, of course, go further. There are data visualization libraries. There are data frame libraries which are very useful when you manipulate arrays. Here, for example, there is a rendering of an image. So you can use the use keyword, the use to have a library to render an image.
I think there is Ktor also available for.
Yes, there is Ktor client, which has been shown during Kotlin Conf. There was a conference which showed how to use a Ktor client. So it can be also a way to document and test your APIs. So you can also run it. So here it was run from VS Code using a plugin. But you can also install the kernel on your machine and install a local server. So you can also host a server that can render or that can execute Jupyter notebooks. So if you want to have demos, documentations hosted online, you can do it with Jupyter notebooks. Some plugins are even available thanks to WebAssembly. They don't need server-side rendering. Some plugins are rendered on the browser. That's not still the case for Kotlin, but at least if you have a server that renders the page, that serves the page, you can do it. So as you can see here, you see the code source of the current demo. Just to show you, so this web UI, how it can do, what are its features. You can, for example, export to a PDF. So here's just to show you also how to set up this. You have to install some things. So it's some Python libraries and tools. When you finish installing everything, there's still always some things to install later, of course. But I think so. We need to install also Chrome Playwright. And here you have a PDF which renders your Markdown. So you can render it on a PDF, on a web page, on Visual Studio Code, which is free. And you have also have this on IntelliJ, but which is not free. So the Jupyter Notebook plugin for Kotlin is not free on IntelliJ, or you need to have the Ultimate Edition. But for VS Code, it's available for everyone. So here is it for the notebook part. Now, we're talking about Kotlin. What's also increased our love of Kotlin is the language features, because we all also love Kotlin for its language. That's something that we must not forget, that it works across all platforms, but it's also a great language. So let's remind just one of the best features that I like in Kotlin. It's its native null safety. So just to be fair, compared to Java, you can do some nullish safety in Java, with annotations, with IDE features, with some tools like someone that I discovered recently. I don't have its name here. It's nullaway. Yeah, it's in my note. It's called nullaway. But for example, in Java, it doesn't work with generics. You can't add null annotations to generics in Java. In Kotlin, you have full native language support of null safety, and you have errors on compile time. So it means that with Kotlin, you have 0 null pointer exception errors at runtime when you work with Kotlin. 0 null pointer exceptions. So there is a new feature in Kotlin. There are many interesting features. So this is a great syntactic sugar, which is called explicit backing fields. So Kotlin also has native support for properties. So no more get, set, the 1,000 get sets that you declare in your classes. So here, for example, we have a use case of a property when you have an internal thing, which is a mutable list, but you want to expose a non-mutable list to the outside world. So you expose a type which is different from the type that you have in internal representation of. And you have a shorthand for this, which is called an explicit backing field. So it's a syntactic sugar to expose a type which has more restrictions than the internal type, which is the field contextual keyword. So it's a contextual keyword. It means that field outside of this case is just a normal identifier. Another feature which is in discussion. So in Kotlin, it's public, the evolution process. It's called the Kotlin Keep, K-E-E-P. And you have all the evolutions of Kotlin, which is public. People can discuss, give their opinions. And this is an example of something that they are working on, which is collection literals. So it allows to define collections with less code, similar to what you see in Python, for example. And there are many, many more features that will arrive in Kotlin. And thanks to the release of Kotlin 2, because before the release of Kotlin 2, we didn't get too much language features, because they're really working on stabilizing the new language. simplifying the migration. But now with the release of Kotlin 2, we're seeing many more new features coming, and many more are to come. Like we have been seeing in some years ago when Kotlin was released, like we have seen many interesting features from the language. Okay, now I hope that your love is complete, is full. And
Full of love.
let's give our conclusion. So what do you have to say on KMP, Ibrahim?
I will be very short, but there is two main parts of improvement, the tooling side. So Gradle, you will discover Gradle even if you are an Android developer, if you're starting up a KMP project, because Gradle is at the heart. Of course, you have less, if you know the cross-platform, the previous cross-platform technologies, less code specificities and almost nothing, but lots of work on the computation on the build system and programming. Also iOS improvement, especially on the build system side. It's still some scripting obscure that you try to deal with. It's improving more and more each month. And on the architecture side, I think it's almost okay now for mobile and desktop. Still some work on WASM and web target.
So, is it time to onboard? For me, yes, it's time to onboard. What do you think, Ibrahim?
Definitely. And if you are an Android or mobile developer, just open your minds. It's a really good start. On my perspective, I really enjoy now to make backends development, for example, with Ktor. It's more and more interesting for mobile developers to open their minds to other technologies.
Yeah, so it's really time to consider Kotlin seriously, especially with the release of Kotlin 2, with the stabilization of KMP. So really it's time to at least take a look. And we have an internal training for that if you're interested. Please don't hesitate to contact us. Some advertisement, of course. Huh? Please don't hesitate to share, like, subscribe, you know. And of course, one of the biggest advocates is our colleagues from Madrid, which are even appear in the official Kotlin website because they have some feedback about Kotlin development. So thanks to colleagues from Madrid.
And two other things to share. First, Worldline was sponsor of the Kotlin Conf this year. So we have our logo on the Kotlin Conf this year. So very happy for that. And also we have another presentation with Marco, Antoine this afternoon if you want to go deeper on KMP. So don't hesitate to go there.
And they have also a booth if you have any questions on real feedback. And Stevens also.
And Stevens also.
Yeah. Of
the
course.
Stevens. I think we are out now. The presentation is complete. Thank you very much for your attention.